Democritus was a philosopher born around 460 BCE who created the atomic theory after traveling Asia using his father's inheritance. But many years later, Aristotle was born, another philosopher who discredited the atomic theory and instead added a fifth element to the previously known classical elements. Democritus's philosophy was the atomic theory, which he expanded off of Leucippus's. He believed it was impossible to divide something like sand again and again forever, but rather believed atoms to be impossible to split. Aristotle's philosophy about particle theory was also expanded off a previous theory. He used the classical elements like earth, water, air, and fire to explain everything in the world was made up of different combinations of those elements, but also proposed a fifth element, aether, to explain what the stars and skies were made out of. Democritus believed the end the atoms existed and it being a unit of matter, while Aristotle believed instead in the known elements and did not believe in the atom or it being a unit of matter. Here you can see the atom, which was in Democritus's mindset the smallest unit of matter. Their ideas fit in the timeline of history as Democritus' theory and the atomic theory would expand over the centuries, while Aristotle's ideas and philosophies would be used for his other works and expand human thinking for seemingly forever. John Dalton was born in 1766 and became an English chemist and was influenced greatly by the Quaker religion. He had an atomic theory that was made up of 5 key points about the atoms: that all matter is made up of small particles called atoms, atoms of the same element are identical, atoms of different elements are different in their physical and chemical properties. Atoms cannot be created, destroyed, or changed, but can be combined, separated, or rearranged in chemical reactions. And finally, atoms of different elements combine to form compounds. He recognized that the total pressure of a mixture of gases is equal to the sum of each individual's contributions added together to test his theory about atoms, and his theory was the first to create a relative mass of these atoms, going so far as to find that oxygen is about 5.6 times heavier than hydrogen, and revived the 2-century-old atomic theory. The next major scientist is J.J. Thomson, who was an English scientist, and his work led to the belief that the atom was indeed divisible, and there were smaller subatomic particles within the atom that had positive and negative charges. Thomson studied cathode rays, a beam of electrons, but he did not notice at the time. Thomson conducted various experiments on cathode rays, first studying how they react in their charge before attempting to deflect this beam using another electric field. The plum pudding model was a model of the atoms that consisted of a positive field where negative charges, these electrons, were scattered among them, much like the plum of a plum pudding are. Here you can see his model with electrons scattered throughout a positive field, and also a picture of plum pudding. His theory fit in the timeline as his theory of negative and positively charged subatomic particles was correct, but his model was off as the atom is comprised of mostly empty space. Thomson's theory held up great over the years as he made many advancements in the idea of the atom and its elements in his time, without being able to see the atom itself. The next scientist was Ernest Rutherford, a New Zealand-born citizen who discovered that atoms had a small, positively charged nucleus that held up most of the atom's mass, with low-mass electrons orbiting it. The gold foil experiment was conducted by him by firing positively charged alpha particles at a thin gold foil. Most of the particles passed with little deflection, while some deflected at large angles, leading him to believe that atoms consisted of mostly empty space, and instead had a concentrated center point now known as the nucleus. Niels Bohr contributed to this model by showing that electrons travel in separate orbits around the positively charged nucleus, and their number of valence electrons determine an element's property. These models came out in the early 20th century, and scientific research on atoms continued to push forward in the next and final model of the project, the electron cloud model. James Chadwick, not the actual inventor of the electron cloud, but rather helped to its invention, discovered the existence of neutrally charged particles within the nucleus with the protons, the